Let's shift gears just a bit right now and talk about SD Access, software-defined access. This is going to solve a problem that has frustrated network administrators for years. Because we have traditionally written an ACL, an access control list, to say something like, I want to allow subnet 192.168.1.0/24. I want anybody in that subnet to be able to reach a server with an IP address of 192.0.2.3. And in this scenario, PC1 is going to be able to get to the server because their IP address is part of the 192.168.1.0/24 subnet. But here's the problem, and as an example, I used to work at a university, and I cannot tell you how many ACLs that I had to maintain. Let's say that a professor needs access to a grading server, and maybe I permit the IP address of the laptop in their office to get to that server. But what happens if that professor goes over to the library and they try to get to that server? Well, in this example, the professor's PC, PC1, it has changed subnets. It has changed IP addresses. It now has an IP address of 203.0.113.125. So when it tries to reach that server, it's going to be denied. And that's not what we want. We've got the same person with the same role and the same laptop, but because their IP address changed, they've suddenly lost access. What we really want to do is to grant access based on who someone is, not what IP address they happen to have at the moment. And that is exactly what SD Access delivers. And at the heart of it is Cisco's Identity Services Engine, or ISE, and we pronounce that ICE. Here's how it works. When we connect to the network, whether we're plugging into an Ethernet port or we're connecting via Wi-Fi, we're going to authenticate with that ICE server. It could be based on a username password combination. It could be a certificate, maybe a MAC address of a device. But ICE is going to verify our credentials and say, for example, okay, Kevin, you just logged in. You're a member of the faculty group. And as a result, I'm going to assign your traffic a security group tag, or an SGT of 50. And that SGT, that security group tag, it's going to follow your traffic throughout the network. And let's say that server 1 belongs to a security group with a security group tag of 10. Now, instead of writing an ACL that says permit a specific subnet to reach a specific IP address, we can instead have an ACL that says permit SGT 50 to access SGT 10. This is not just an ACL, it's an SG ACL, a security group access control list. And if Kevin is that professor we talked about in their office, are they going to be able to reach the server? Yes, they can, not based on their IP address, but based on their identity, which means if they go across campus and connect to the library's network, can they still get to the server? Yes, they can. Again, IP addresses are not controlling access. Access is being controlled by identity, and the identity is associated with a group, and that group is going to be associated with an SGT, a security group tag. And our SG ACLs, our security group access control lists, those are going to have rules based on those security group tags. Now let's take a look at how SD Access is organized. Cisco breaks it down into 4 different layers or planes, and I think visualizing it this way really helps you understand how all the pieces fit together. At the bottom, we have the physical layer or the physical plane, and that's exactly what it sounds like. These are the actual devices that you touch. It's your Catalyst 9000 series switches, it's your wireless access points, routers, firewalls, the endpoints themselves like laptops, phones, printers, IoT devices. And then moving up to the network plane, this is where things get interesting. The network plane has 2 parts. It has the underlay network and the overlay network. And the underlay network, that is our physical network infrastructure. And oftentimes in an SD Access topology, it's running ISIS as the routing protocol, intermediate system to intermediate system. That's not a requirement, it's just a really common routing protocol that we see here. And the underlay network is providing basic IP connectivity between our multi-layer switches. Then virtualized on top of that, we have the overlay network. This is our virtual fabric where we can have these encrypted tunnels that can interconnect our switches across a layer 3 boundary. And that's going to be using technologies like Lisp and VXLANs. Lisp, which stands for Locator ID Separation Protocol. We're going to discuss that much more in our next module. But Lisp is going to associate the endpoint identifier, the EID of a device, with an IP address at a specific location, and that's called the RLOC. So I could move my endpoint ID from one location to the other, but when I do that, there's going to be a mapping server that knows that my endpoint ID is reachable by going to a specific router's IP address. That's the RLOC. And VXLANs allow us to tunnel across this virtual fabric. This is what lets us have layer 2 connectivity even though we're crossing a layer 3 infrastructure. And again, we'll talk a lot more about Lisp and VXLANs in our next module. Next up is the controller plane, and it has two key players, Cisco Catalyst Center and Cisco ICE. And Cisco Catalyst Center, formerly known as Cisco DNA Center, it's going to provide fabric control functions. It's going to act as that Lisp map server that I alluded to a moment ago. It's going to distribute policies throughout the network. It controls how the fabric operates. And you might notice that we have a Cisco Catalyst Center icon down at the physical plane as well. And that's because it can be a physical appliance, but it's providing a controller function here. And we're about to see that it also provides some management functions. Oh, and by the way, in order for a configuration to truly be an SD-Access configuration, it must include Cisco Catalyst Center. You could still have a campus fabric, but unless it's controlled by Cisco Catalyst Center, based on Cisco's definition, it's not truly an SD-Access network. And we also have Cisco ICE at the controller plane, the Identity Services Engine. This is going to handle all of our authentication and authorization. And when a user or device connects to the network, ICE, they figure out who they are and assigns them a security group tag, an SGT. And those SGTs, those are the foundation of what Cisco calls our TrustSec policies. And finally, at the very top, orchestrating everything is the management plane. And living at the management plane is Cisco Catalyst Center, specifically the graphical interface of Cisco Catalyst Center. This is going to give the administrator that single pane of glass to manage the entire fabric. It's going to handle automation, orchestration, assurance, policy management. You design the network here, you push out configurations here, you monitor the health of your network, you troubleshoot issues, all from this Cisco Catalyst Center GUI interface. And finally in this video, let me break down the roles in an SD-Access fabric. Down at the bottom, we've got the end user devices that are plugging into the network. Things like printers, access points, laptops, computers. And those end user devices, they connect into Fabric Edge nodes. Now, the Fabric Edge nodes are acting like switches. This is where ICE is going to suddenly say, all right, once you've logged in and we see that you're a member of a specific security group, we're going to assign you an SGT, a security group tag. That tag assignment happens here in the Fabric Edge nodes. And the Fabric Intermediate nodes, they make up the physical underlay network. This is where the routers and switches are physically interconnecting. The Fabric Control Plane node, it's going to be running Lisp. It maintains that mapping database, so we know what RLOC to go to reach a specific endpoint ID. And if traffic needs to leave this SD-Access fabric and get out to the rest of the world, that's done through a Fabric Border node. It's going to connect us out to the rest of the world, and there are three types of these Fabric Border nodes. First up is the internal border node. This is going to connect us to trusted networks within the organization. There's the default border node. It's going to connect to untrusted networks like the internet. And an anywhere border node can connect to both inside and outside public networks. And there's one more role I want you to know about. It's a fusion router. And the reason we might need a fusion router is that SD-Access uses VRFs, virtual routing and forwarding. This is like having virtualized routers all sitting inside of one router, and their routing tables can be separate. For example, we might be able to maintain one routing database for tenant A, another routing database for tenant B, another for tenant C, and so on. But there might be times where everyone needs to reach a specific service like DNS or NTP. Well, the Fusion router is going to be able to leak those routes. Here's how you get to the DNS server. Here's how you get to the Network Time Protocol server. It's going to be able to leak those routes into each VRF, each virtualized routing environment, so that they are universally available. That's a look at the SD-Access architecture, and next up, we'll log into Cisco Catalyst Center, and we'll see how all this comes together in the management interface.